I have here a Commodore 64 board 250425 revision, and I've got an oscilloscope probe hooked up to ROM high, and I've got the scope set to, or the probe set to 10x, and I'm using a genuine ST M27C512 EPROM. I'm using this as a PLA substitute, and I'm going to check the waveform on this Tektronix 2430A digital oscilloscope. I've got peak to peak voltage check on channel 1, I've got frequency on channel 1, fall and rise on channel 1 set, and I've got channel 1 set at 50 millivolt divisions, and the sweep time is 2 milliseconds. And I've set upper and lower cursors just as a visual border so that you can see how the waveform behaves. What I'll do is I'll switch this chip out with other PLA substitutes that are EPROM based and not EPROM based, and we'll see what the waveform looks like. And I'll use these cursors here as comparisons. Okay, I'll turn the power on now, and this is the waveform, and it sits in these two cursors. The peak to peak voltage is roughly about 60 millivolts at the top end, that 64 I just saw there. And what I'll do now is I'll switch out this chip for another one. This is a ST M27C512 EPROM acting as a substitute PLA. This ST is a clone or a fake or a knockoff, and it actually has a production stamp stating it's made in China, and it is absolutely 100% non-genuine. And we'll test this on the oscilloscope now. So I'll just turn the oscilloscope on, I should say the computer, and we can see here the waveform is very, very similar to the original ST EPROM. The voltage is about 70 millivolts peak to peak. I think I saw it running at 68, 64, 62, 60. So it's a little bit higher than the original ST by a few millivolts. And I'll switch out this chip for another one now. Here's another PLA substitute EPROM. This one is another knockoff or fake, and it's an ST M27C512 EPROM. It's a one-time only EPROM, and we'll try this on the oscilloscope now. I'm turning the computer on now. And we can see here the waveform is between the two cursors as in the other two examples, and the peak to peak voltage I've seen at about 62, probably run a little higher. Hopefully we'll see that. Maybe not. 64, I think I saw. And the waveform stays within the two cursors that I've set out, and these cursors are just there for visual reference so that one can see if they extend past the border. Okay, I'll go on to the next EPROM. This one's another fake EPROM PLA substitute. This one's a ST M27C512, and it's a knockoff. This is the original one that I discovered seemed to work pretty well, and we'll try this on the oscilloscope now. I'll turn the computer on now. There's the waveform, and there's the peak to peak voltage. Saw 60 millivolts peak to peak, there's 64, 60, 56, 56 again, 62. So it's about the same as the other three examples that we've run so far. 64 again. So I'll stop this and I'll put in another EPROM PLA substitute. This one here is a Winbond 27C512 electrically erasable EPROM being used here as a PLA substitute, and this one don't work whatsoever. You put it in, turn the computer on, and it's just a mess every time. The computer will run, do calculations, things like that, but the screen's got a lot of graphical artifacts, and yeah, it's not worth running one of these particular ones in here. And we'll do a oscilloscope check now, and I'll turn the computer on, and I've got the cursors set up in the same fashion as I have before. I haven't altered any of the settings on this oscilloscope, so we can get a quick look and see how this one differs in waveform to the others that we've tried. I'm turning the computer on now, and you can see quite clearly that it's dipping a lot, and I've seen 110, 128, 130 peak to peak millivolts on the oscilloscope here. 124, 144, 146, 122, 90, 120. So this one really does cause a lot of issues when running. 138, and you can see it doesn't rise a whole lot more than the others, but it dips quite a lot towards zero, and I think that's where you get the erroneous data being put on the system. See if we can get a high number reading. No, not going to happen. That's okay. So we'll move on to the next chip under test. This one here is a proprietary PLA substitute. This one is called the Ultimate PLA, and it's commercially available online. This is just something I happened to pick up because I needed one, and we'll see how this one operates under the oscilloscope. The settings have remained the same. I haven't altered anything, and I'll turn the computer on now. Okay, this is quite a bit different now. The base voltage is actually below the cursors, so it's almost if it's 50 millivolts per division, so it's maybe 75 millivolts, maybe below where the other EPROM based PLAs were running. and the peak to peak voltage there is 132, 140, 136. This one actually works extremely well. I've never had a problem with it, but it is very interesting to see that the base running voltage is quite a bit lower compared with the EPROM based, and you can see the signal's quite broad and varied, and we're getting 136, 138, so it's quite noisy, bit of a dirty signal. I'll move on. I'll see if I can find an original Commodore factory PLA, and we'll see what that looks like. Okay, now I have a genuine Commodore factory PLA. This one's actually a later model one. I think it might have a date code of 1986 on it. It's made in Hong Kong, been stamped on the bottom of the underside of the chip. I put a heatsink on to keep it cool because they do run very, very hot. We'll put that on the oscilloscope now and we'll test it. Now I've kept the order settings the same as in the previous runs, and we'll turn the Commodore on now, and the Commodore's running, and we can see the signal being generated is low as before, similar to the proprietary PLA called the Ultimate PLA. This one, the signal is quite noisy. You can see here the peak to peak voltage is running about 120. I think I saw 130 before. See if we can hit 124, 120, 132. So it's quite a varied signal here, and it's quite a bit lower in voltage, in base voltage, to the EPROM based PLA substitutes, but this definitely a lot noisier.